Welcome to EDU World Space.
So for part A, let's go ahead and find the partial sum S10. So that's the sum where we start n at 1, stop at 10. So in this case, all the way up until n equals 10, and in that case, go into a calculator. We can round off here. So that's our approximation, and then we'd also like to say what the error involved in the approximation. So here we'll use the formula. All right, so this will be our error here after using n terms. So in our case, using n equals 10, we'll have negative 1 over 3 using the power rule. So just 1 over 3,000, that's the only error that we'll have, or upper bound for the error. Let's go on to the next page for part B. So this is where we'll use formula 3 with n equals 10 to give an improved estimate for the sum. So in this case, using 3, okay, so in our case, go ahead and plug in n equals 10. Now we can evaluate these integrals. We actually just evaluated this one a moment ago. This one over here. Use the power rule again. So, and also using the fact that we already computed this one on the previous page and got 1 over 3,000. So putting these together and the fact that we already estimated this, so recall this was about 82037. Let me double check that. 82037. Yep. So now plugging all this information in to the previous inequalities we had, we get the following. Plus 1 over 3,993. That's a lower bound for the sum. And then upper bound is plus 1 over 3,000. So just go to the next page and simplify that. Simplify those sums. And now we have a better idea of an approximation for the sum. And you can even go ahead and just take the average of these two. So taking the average, And there you could just run that off to about so that'll be our estimate for part B. Now for part C, we'd like to go ahead and actually compare your answer in B with the exact value given in exercise 35, which ended up being pi to the 4th over 90. That was the exact value of the infinite sum. Or in other words, this is the value of S. So in this case, we just want to look at the difference between pi to the 4 over 90 minus our term up here in part B. And going to a calculator, this is a very small number. 5 zeros after the decimal, and then a 4/8. All right, there's one more part here. Let's go on to the next page. This will be part D. And here we'd like to find the value of n such that the following, such that Sn is within 0.0001 of the sum. So what this really means is and that should have been 4 zeros, sorry about that. 4 zeros and then a 1. So let me come back here and fix this. So now we have the following. Rn n to infinity f of x dx. Now we can just evaluate this integral. It's improper, but it's still doable. Use the power rule. And when we plug in infinity, you get 0. So this ends up just being 1 over 3n cubed. And you want this to be less than 0.00001. So go ahead and solve this for n. So you need n to be larger than 32. So you can go ahead and just take n to be 33, or even anything larger than that will be fine. So as long as you're choosing any value of n that's 33 or larger, then that will ensure that Sn is within this number of the S.